Forget about dollars, forget about GDP. What if the real currency of intelligence, both for us and for AI, isn't money, but just pure, raw energy? We're about to dive into a paper that makes a fascinating argument that to really get a grip on the future, we need to stop counting cash and start counting joules. So let me ask you, what do you think is really fueling this AI boom? Is it venture capital flowing into startups? Is it the raw compute power? Well, the answer is actually way more fundamental than that, and it's probably not what you think. It's this: gigawatt hours. Right now, believe it or not, some of the biggest deals being struck in the world of AI aren't about dollar amounts. They're about massive commitments of energy. We're talking about a whole new way to measure value here. This is the real currency. But that brings us to a huge problem. Our entire economic system, the one built on dollars and labor costs, it's completely broken when you try to apply it to this new reality. It has no way to properly compare the intelligence that comes out of a power plant with the intelligence that comes out of a human brain. Think about it like this. It's the perfect analogy. Using our old metrics like GDP to compare human and artificial intelligence, it's like trying to measure a fever with a yardstick. It just doesn't work. They are fundamentally the wrong tools for this job. We're measuring length when we should be measuring heat. So, this paper proposes a pretty radical new ruler, one that's based on the most fundamental currency of all, the energy cost of any action, of any thought. And to do that, we have to go deep. I mean, all the way down to the level of basic physics. And I am not kidding when I say all the way down. This number you see here, 0.018 electron volts, that's the absolute rock bottom physical minimum amount of energy it takes to flip a single bit of information. It's a concept called Landauer's principle. You literally cannot be more efficient than this. It's the floor, set by the laws of thermodynamics themselves.
Okay, so that's the absolute limit. Now let's compare that to our best technology, our most advanced, efficient transistors, the little switches that power everything. They use about 60 electron volts for one operation. Now do the math. That's over 3,000 times less efficient than what physics says is possible. I mean, they're amazing feats of engineering for sure, but on a cosmic scale, they're wildly inefficient.
And this is where it gets absolutely mind-blowing. Let's look at biology. The basic energy transaction happening in your cells right now, the conversion of ATP to ADP, it releases about 0.3 electron volts. That is unbelievably close to the hard physical limit. Life is operating at an efficiency our technology can't even touch yet, running just barely above the random noise of the universe. So, to build that universal ruler, the paper creates this really cool concept, the quantum of intent. Just think of it as one single, purposeful, tiny action. And to make the math easy, we'll just standardize it at a nice round 1 electron volt. And just like that, we now have a single unit we can use to measure and compare everything. All right, so now we have our universal yardstick. So let's use it. Let's scale it way up and compare the two main players, the energy cost of a human thought versus the cost of an AI-generated word. This brings us to what the paper calls the moment of parity. And here it is. This is the big whoa moment of the paper. When you do all the calculations, the energy cost for a basic unit of human thought comes out to roughly 10 to the 18th power electron volts. And the cost for a really efficient AI to generate a single word, it is in the exact same ballpark. We have officially reached energy parity. But we have to be super clear here. This is not an apples-to-apples comparison. That human thought is a massively complex event, right? It's mixing together memory, context, sensory data, emotions, the whole shebang. The AI word, on the other hand, is a statistical output, a very sophisticated one, but still. They cost the same energy, but the kind of intelligence you get for that energy is vastly different. And that's exactly why this moment of parity is so important, but also so fleeting. See, it's not the finish line, it's the starting gun. It's the beginning of a huge race where the competitors are not even close to being on equal footing. I mean, just look at the fundamental difference. Our hardware, the human brain, it's an absolute masterpiece, but it's pretty much static. Our operating system updates over evolutionary time. AI hardware and software, on the other hand, are improving exponentially, like every single day. This quote from the paper just says it all perfectly. The efficiency of AI is on a brutally steep upward curve. Any point where we look like we're on the same level, it's just a temporary crossover. We're on two completely different paths. Biology just can't keep up with that kind of pace. And then, as if that wasn't enough, you have to consider the fuel. This highlights a massive economic advantage for AI. I mean, the cost for a unit of energy, a joule, from electricity is just orders of magnitude cheaper than the cost for that same joule from food that humans need. So even if our brains were just as efficient, our fuel is way, way more expensive.
So, where does all this leave us? What is our value in a new economy that's going to be increasingly defined by energy efficiency? This is where it all gets very practical and, frankly, a little bit scary. The paper argues that our value has to shift away from doing the labor and toward defining the purpose behind it. We become the ones who set the goals. We are the final judges, the ones who look at what the AI created and say, yes, that's what I wanted. Our job isn't to row the boat anymore. It's to steer it. And all of this leads to the final, really critical question. As AI systems march closer and closer to perfect efficiency, the challenge for us isn't about creating value anymore. It's about deciding what value is even worth creating. In a world where machines can do almost anything, what is our purpose? What's the intent that we choose to set? That's the question that every single one of us is going to have to answer.